okay? And dishwashers use a lot of electricity, so.
One of the things, as soon as you get the smart meter, as long as you have a home computer and can get on the internet, you can enter into agreements with the utility. Like if you want voluntary price reductions, that's available. You don't need all the wired wireless home to get involved with it just at this point.
I'm guessing they probably will do it by text message too if you choose that. So.
The current version of the National Electric Code has taken all this new stuff into account. Notably that a lot more people are going to have electric vehicles, either hybrids or completely electric. Well, if you have that, that means you've got energy storage in the case of your batteries. And if we connect up what's called an inverter that changes DC to AC, you've got backup power should there be a problem and you lost your power from the utility.
During Superstorm Sandy a few years ago, when a good chunk of the East Coast lost power, again for several days, there was a guy in New Jersey who had Nissan. Nissan's whatever their electric vehicle is. And he has a conversion kit for the Nissan that allowed him to run, basically plug in several appliances, his mission critical things. You know what those are? Refrigerator. Plugged in his refrigerator so his food wouldn't spoil during the power outage. And so he was able to run just on the stored energy from his electric vehicle. He was able to run his refrigerator for 3 days. So he was a very popular guy. He was the only one who had cold beer during the entire blackout there.
There are a lot of companies that are entering into the market. This is Grid Rabbit. And they have door sensors, window sensors, a smart thermostat, smart outlets. You know, all this technology is there that you can integrate into your home as you see fit. The one item, the video camera, that makes me a little concerned. Somebody's going to be able to have, look at my living room or what have you. And I was discussing this with Tom Lombardo, and I said, when I got married, I had a cat, and still do. And the wife had an African gray parrot. And so you didn't want to go too far or gone too long without being able to check to make sure the cat was leaving the parrot alone. But I fixed the cat. I don't mean like at the vet. I taught the parrot to say meow. And so I've got this conflicted cat. He doesn't, I don't know, it looks like food, but he talks like me.
Yeah, some of the smart home technology isn't directly related to energy. Sometimes it's convenience and home security as well. For example, if I had this video camera, I would actually mount it outside my house and towards the front door. And so with some of this technology, what I could do is I've got a video camera mounted outside the door. It's motion sensitive, so it's turned off until it senses that somebody is there. Somebody walks up to the door, and I can get a video screen, and I can see it on my phone. Suppose I'm away on vacation, several hundred miles away, and somebody comes to my house. Well, if I also have a speaker outside, then they ring the doorbell, and my phone buzzes, and it tells me there's somebody at my door. I can actually talk to them. I can say, what do you want? What are you selling? Oh, I don't want any. And they go away. They don't know that I'm not in the house, okay? Other things like remote locks. I don't know if there's a remote lock on there, but there are locks that can be unlocked and locked and unlocked remotely. So you go away on vacation and you think, did I lock the back door? Or you go away on vacation and you realize, because you have a window sensor here, that you left a window wide open and you're going to be gone for 3 weeks and it's going to rain. And so what do? You call your next door neighbor to go over and close the window. He doesn't have a key. That's okay. When he gets to the door, I'll see him on the camera. I can unlock the door remotely, let him in. He closes the window, he leaves, I lock the door again. Okay? And again, energy management. If we're away in the summertime and it's really, really hot and we're on our way home, what I usually do with a thermostat is I set it to a temperature so I know the air conditioner is not going to turn on while we're away. But let's say we're driving home and it's 90 degrees that day. I would really like the house to be cool by the time I get there. Okay, so we're on Interstate 90 and we get to around Elgin, so about an hour away from home, flip on my phone and say, turn on the air conditioning now. Okay, so by the time I get home, it's comfortable. So those are some of the things, part of it is energy management, but it's also convenience and security. This is, if you looked at our power consumption throughout the day, consumption is the total area underneath here, and we pay for electricity using a unit called the kilowatt hour. That's the basic unit of electrical energy. Demand, which is measured in kilowatts, that's how much you're taking at any instant in time. And if you look, early in the morning, we're not really using a lot of electricity. It peaks somewhere in the mid to late afternoon, and then it kind of tapers off. The problem is the utility has to be capable of delivering this amount of electricity all the time. And it's very expensive to have this much generating capacity when you're really only selling this much. What they would like to do is, ideally, they'd like to just smooth this out into a nice straight line. Okay? Well, that's never going to happen. But if we can at least make it a slight hump rather than this giant spike in the middle, then that will help a lot. So keep in mind a couple of terms here. Consumption in kilowatt hours, that's what you get charged for. Demand is how much you pull at any instant in time. So if I plug in a whole bunch of high power appliances and turn them on all at once, I'm getting really high demand. Business and industry has known about this for a long time because they pay demand charges. I first learned about this when I was a college student and I worked at a McDonald's and I was the opening manager. And they told us when you come in, you turn on one thing and you wait 15 minutes for it to warm up before you turn on the next thing. Okay, all of our grills and everything, all the deep fryers were all electric. And they said, if you come in and you turn on everything at once, we're going to get a huge demand charge. And that's when I learned what a demand charge was. Right now, as consumers, we don't pay a demand charge, but one of the potential pricing schemes does involve a demand charge. So you may have to deal with that at some point. So what I did was I took a look at a typical American home, and these are just using numbers that came from the Department of Energy. Typical American home, we're talking 3-bedroom ranch, 4 occupants living there. Typical home uses about 1,024 kilowatt hours of electricity every month, and the maximum power draw at any instant in time is about 3.6 kilowatts. And what I did was I crunched a bunch of numbers. I created a spreadsheet and I looked at a bunch of different scenarios to figure out how can you save money on your electric bill. So there are different rate plans. In one case, and what I did, again, I don't know exactly what ComEd is going to do here, but it's probably something very similar. This was a power company in, I think, one of the Carolinas, somewhere around there. And I found that they have one plan. We're going to show you 2 competing plans. They have one plan where you can pay $18 per kilowatt of your demand charge. Now, if you remember on the previous slide, I said that our typical demand on average is about 3.6 kilowatts. So if you multiply that times $18, you get about $65 or so. So you're going to pay about $65 every month just for your demand charge. Okay? In exchange for saying I'll pay the demand charge, you're going to get a very low electric rate. Do you know how much you pay for electricity right now per kilowatt hour? On average, depending on what region you live in, it's about 10 cents per kilowatt hour. Okay? So in exchange for accepting this demand charge, they're allowing their customers to pay only 1 cent per kilowatt hour during off-peak times and 10 cents per kilowatt hour during peak demand times. So that's about, the national average is about 12 cents, so we actually get off a little bit low here. But they're giving their customers the option of choosing that as their electric plan. There's another option in which you pay no demand charge, so it doesn't matter how quickly you draw the energy, it's based on how much you draw and what time you draw it. So if you take no demand charge, you're going to pay 5 times as much per kilowatt hour during off-peak hours, and you're going to pay twice as much during peak hours. So you have to look at your exact scenario. So my numbers may not match your lifestyle, but we'll look at different types of scenarios. So if you don't do anything, and you have a choice between these 2 prices, what I did was I calculated your monthly energy cost for how much you're drawing during peak hours, during off-peak hours, factored in the demand. And that's probably, your typical electric bill is probably in the $100 range, I would say. Mine is about $100 a month typically. And I have an all-electric house. I don't have any gas, so all my appliances are electric. So $120 to $132. There's not a whole lot of difference between those 2 choices, okay? But there are a couple of ways that you can reduce your electric bill under either of these plans, under both of these plans. Okay, one is to use a principle called load shifting, which means we use electricity when it is less expensive. So if I can, like I said before, if my dishwasher, I load my dishwasher and I've got it ready to go and it's 6 o'clock in the evening and 6 o'clock is still peak demand times, my dishwasher might say, hey, why don't you wait until 7 o'clock when it's off peak, okay? Now, I can do that myself. I can say, hey, I'm just not going to push the start button until 7 o'clock. But I'm kind of absent-minded, and in the evening after work, I might not even think of that. So it might be tomorrow morning before I actually think to push the button. So it would be nice to have a smart appliance to do that. So that's load shifting. That's using electricity during off-peak hours at most of the time. And then the other alternative is to generate some of your own electricity using renewable sources. So load shifting, of course, means running your appliances during the green hours, the off-peak hours, rather than running them during the peak demand hours. And as I said, there are smart appliances that can automatically do this. They will be able to. Right now, there's not a lot of these on the market. And it's a brand new technology. And I don't know about you, but I kind of wait for the 2.1 version of any form of technology. You get the 1.0, and that's the prototype. They shouldn't even be selling that stuff. The 2.0 revision is where they make major changes, but then they didn't get the bugs out of the major changes yet. So I like to go with 2.1. That's when most of the bad stuff is worked out of there. So I'm not on board with, I went the wrong way. There we go. I'm not on board with the buying the smart appliances just yet, but in a couple of years, we'll have some of the next generation. And again, they're not designing these, it's kind of hand in hand. Until the smart grid and smart meters start appearing, the appliance manufacturers don't really know how they're going to work. So this is going to be something that will take place probably over the next 5 years or so. Yes?
Are they looking at making adapter kits or something for existing? So you have a smart outlet?
Yes. In fact, you could do something like one of these. This is an outlet. You could remotely control any 120 volt AC appliance with this. So yeah, you can retrofit something. And that'll be the first generation. So you wouldn't have to buy a new washer and dryer. You would buy the adapter for it. Probably more complicated with the dishwasher because that's hardwired in. More complicated if you have an electric dryer because that's 220, not 110. But yeah.
Although I have to mention one of our capstone projects.
That's right.
They took the WeMo for 120 volts, and the students designed an interface to make it work off 220. And the application is a colleague that wants to be able to turn an air conditioner on and for his home in Wisconsin a couple hours before he gets there. So,
So he couldn't wait for the smart appliance, smart thermostat, so he's did it that way. Okay, so if we go back to the comparison, if you do load shifting, so this is really very little impact on your lifestyle other than using electricity at off-peak hours, and no investment involved in this if you do it all manually, if you don't buy smart appliances. If you do load shifting, you can actually reduce your electric bill from, what was it, around 120, 130 to 65 or 91, depending on whether you go with the demand or the non-demand pricing. So there's a pretty significant impact there. You can save about 56, minimum of $40 a month on your electric bill. Okay, I like this much better because I like to be able to generate my own electricity. And so if you were to put, let's say, as Steve said, you don't have to necessarily buy a massive photovoltaic array, a massive solar array like this. You can buy it in pieces and gradually scale up. Or if you want to make the investment all at once, you can buy the big system. I did my calculations based on a 5 kilowatt system, which right now would cost, complete with everything installed and everything, is about $15,000. That's before the government incentives, and the federal government has just renewed the 30% tax credit. So for up through 2019, I believe, the tax credit is still good. So that means if you buy a photovoltaic system, you can get 30% of the cost back. So that $15,000 system is now in the ballpark of $10,000. And if you do that, here's what your electric bill looks like. Check this out. Peak hours, 0. Why is that? Do you remember when peak hours were? Mid-afternoon to evening. What's happening during peak hours? That's when the sun is shining. That's when you're generating most of your electricity anyways. In fact, during peak hours, it's very likely that you're selling electricity to the grid. So I actually factored that in as well. So I factored in the fact that, you know, during peak hours you're generating more than what you would use and you're selling energy back. And how's this for an electric bill? $22 to $24 a month. Sound pretty good? I could handle that. Okay, so you can save, you know, about $100 a month by putting that up. I calculated the payback period on that. Without the federal tax credit, the payback period is about 12 years. With the federal tax credit, it's about 8 years. Okay, so if you're going to live in your house for 8 years or more, it's worth your while to do this. Even if you're not going to live in your house for 8 years or more, it actually improves the resale value. Studies have shown that having solar panels on your house will improve the resale value of your home. So you basically have 3 choices, and they affect your average monthly electric bill.
That's me.
Yeah, you can do nothing and pay $125 a month or more. You can do load shifting and maybe pay about $90 a month. And of course, there's no cost to you to do this, but there is a kind of an impact on your lifestyle. Or you can add solar, which has an upfront cost, but no impact on your lifestyle, and pay that much per month. Now, if you want to learn more about this, go ahead.
Rock Valley College, back in 2009, we came up with the Sustainable Energy Systems program. And we've been offering that. One of the components is the smart grid. So we'll talk just a little bit about that. The actual program covers a whole wide range of technologies, from geothermal heating, cooling, solar thermal heating, cooling, of course, renewable energy generation by using photovoltaics, small wind. We've got a strong component of electronics because that is the most mysterious aspect to a lot of people. We do cover the National Electric Code because it helps you come up with safe systems, although this is not a program for electricians. They do system design where they look at energy conservation, energy efficiency, and build in these other components. And then out the right, the smart meter kind of links all this technology together.
So we designed the program so that a graduate can work in the sustainable energy field, but if there's not a job available at that moment, they can also work as electronics technicians. In many cases, there are companies that are hiring them as electronics technicians, realizing that they have energy management skills because they've taken the sustainable energy degree, and they're able to reduce their energy usage using the skills that they learned in the college. NEC is the National Electric Code. Even though we're not training electricians to install, system designers have to know the code because you're designing the system.
We got what we call a smart grid panel. There's a company, Marcraft, that is out in Oregon, and they manufacture this training tool. Basically, it's designed for inside a home with the thermostats, the ZigBee communications, and then a smart meter on the left. At the far right, you have what would be like the service entrance. So if you wanted to do like an inverter with DC to the inverter, you can do that at the service entrance. It was purchased through an iGen grant. iGen is the Illinois Green Economy Network. It links 48 community colleges, well, campuses across Illinois. And there was a $50,000 grant available. So we applied and we got it. Right now, these panels are all being worked on and we're developing curricula. One of the other blessings that we have is Freedom Field Renewable Energy. Freedom Field is a not-for-profit. It's funded and supported by Winnebago County. Freedom Field is part of the Rock River Water Reclamation District, so it's right near the Rock River. They have wind turbines, they have solar thermal, they've got radiant floor heating, they've got all these different technologies that our students need to find out about. If you go to the next one. One of the things that is really key with Freedom Field is it has formed what we call a living laboratory. So the students can go in and they can modify the systems with permission and play with the systems, do experiments with the systems, but these are real, genuine systems, which really, really helps students out when they're trying to find out what's it like in the real world.
Yeah. One example is there's the pump, right? They used a variable frequency drive. Okay, so Steve teaches a course on, it's called variable speed drives or variable frequency drives. The way a pump usually works is it's fully on or fully off. The motor runs or it doesn't run. That's all there is to it. And to control airflow or liquid flow, what you do is you use a valve. And Steve does a great analogy. He said that's equivalent to controlling the speed of your car by putting the accelerator pedal all the way to the floor and just adjusting the speed with the brakes. Okay? You can imagine how much energy you're wasting doing that. Well, a new type of motor control system is called a variable speed drive, and it allows the motor to spin at different rates so that when you don't need a lot of flow, you can just run the motor at a lower power, just like you back off on the accelerator when you don't need to go as fast. Our students, as one of the capstone projects, is that correct? Mm-hmm. They designed and programmed one of these variable speed drives on, which pump was it? Was it the cooling?
Heat exchange pump.
Okay, the heat exchange, okay. And they were able to reduce the energy consumption on that pump by 40%.
Yep.
Just by using a variable speed drive. Okay,
And they're manufactured in Loves Park, Danfoss. So when people talk about, your students when they went through sustainable energy systems, did they get a green job, whatever that is? Well, in my mind, if they got a job at Danfoss making products that reduce energy and improve efficiency, then yeah, they got a green job.
People always think about renewable energy as how do you generate electricity, but the first thing we talk about is how do you reduce what you're using, because it's a lot less expensive to reduce your consumption than it is to generate more. In addition, I teach one of the first courses, or our first course in the Sustainable Energy Systems program is Introduction to Sustainable Energy Systems. I've been teaching that course for several years, and in addition to covering things like energy management, we do a good introduction to photovoltaic power, solar power. We do kind of a broad overview of the other forms of renewable energy. So we talk about wind, we talk about hydroelectric power, batteries, energy storage, and things like that. There's no prerequisite to this course, so if you're interested in this, you don't have to be a student in this program to take it. And the things that you learn, we talk about passive solar, how can you improve your home, if you're building a new home, what things can you do to make it energy efficient, and we talk about energy generation as well. So, thank you. Oh, there's more. What questions do you have? Yes?
You were talking about the different ways to save energy. I was wondering if you've done any number crunching with using like a Tesla Powerwall where you charge your battery at night and have that power your home during the day.
I have. I actually, I do a little writing on the side. I write for a website called engineering.com. And when the Tesla Powerwall was first announced, I did a very detailed analysis of that. If you look for an article called Tesla Powerwall by the Numbers, you'll find my article. What I found was that the Tesla Powerwall is not a good way to save money. The idea behind that, the Tesla Powerwall, if you don't know what that is a battery a storage system, an energy storage system. It uses the same batteries that go into the Tesla, if you're familiar with Tesla electric vehicles. They're very high-end. We can't afford electric vehicles like that. But they're very high-end, sporty electric vehicles. And they use lithium-ion batteries, which are very common in laptop computers and that sort of thing. But they designed a power wall. It's basically a battery unit that mounts on your wall. And the idea is that you can buy energy overnight when it's really, really cheap during off-peak hours, and then you sell it back to the grid during peak hours, or you use that electricity to power your house during peak hours. And I did an analysis of that, and it's probably about a 15-year payback period for one of those. So not really a good thing. I think where the Powerwall comes in, where it'll be really good is for people who want an off-grid, completely off-grid place. So if you have solar panels and you need to store your energy because you don't have the grid to sell it to and you don't have the grid to buy energy from, then I think that the Powerwall is a great idea for that. Right now, people who are doing off-grid are typically using their deep cycle lead acid batteries. They require maintenance. They require, you got to add water. They're temperature controlled. They have to be in a ventilated room because they can off gas. The Tesla Powerwall, the lithium-ion batteries, maintenance-free. 10-year warranty. You put it on the wall and it just works. So I think that's great for off-grid applications. Solar plus Powerwall, but only if you're off-grid. So as long as net metering is in place and they're buying energy back at retail value, which is currently the case, then basically when you sell energy to the grid, when you're generating more than you need, and then you buy energy back, you're effectively using the grid as, we call it, virtual storage. So it's not really storage, but you're saying, hey, if I put 10 kilowatt hours of energy on the grid, and then I buy 10 kilowatt hours of energy from the grid, it costs me nothing. So for all practical purposes, I stored 10 kilowatt hours on the grid. Okay? If you put it in a battery and you get it back, well, that's cost you nothing too, except that you had to pay for the batteries, and those are very expensive right now.
We at Freedom Field, we have a battery bank set up so that, exactly as Tom said, you can charge the batteries when the rates are low and then sell it back when the rates are high. The test system that we have is a little more than that, though. Most inverters, like in solar photovoltaic systems, you have to have something called anti-islanding, meaning that if the grid goes down, your inverter has to go down, so you don't electrocute a technician.
That's so you're not putting electricity on the grid while the linemen are out there working on it. Okay.
But if you design in something called a transfer switch, which is what we did at Freedom Field, then you can run at least part of the facility, taking the DC from the batteries and running into an inverter. You just have to be disconnected from the grid when you do that. But the whole intent of that system was to look at peak shaving and looking at strategies for making money from the utility.
Brian, you had a question?
I was just going to follow up with that. How much are the lithium batteries?
The Tesla Powerwall, let's see, if I remember correctly, it was in the $5,000 range. And that is just the battery unit, so it doesn't include the part called the inverter. Batteries store what we call DC electricity, and what comes out of the wall is AC electricity, and the inverter is what converts the DC into AC. So the Powerwall, I think I figured out it's probably going to be about $6,000 with everything, installation, and the whole works. Yes?
Is there any data on the durability of the photovoltaic? I mean, if it's got an 8-year payback, am I replacing it 10 years later?
No, actually, most PV panels are warranted for 20 to 25 years, and there are actually photovoltaic panels that are still working from the 70s using 1970s technology. So that's 40 years, and they're still in service. Basically, solar panels degrade gradually over time. The general rule of thumb is about 0.5% per year, but I actually did an analysis of that as well, and that kind of depends on the conditions. Under most of the conditions in the northern United States, you're probably looking at about 0.2% per year degradation. What that means is after about 25 years, it's still producing close to 90% of what it did when it was brand new. And because there's no moving parts, they almost never fail. They're extremely reliable. Now, the other parts, like the inverter, the part that converts the DC into AC, those are usually warranted for about 10 years. So you will have to replace that, but that's a much lower cost than replacing the photovoltaic panels. That's your highest cost right there. Okay. Other questions? Yes?
Has the efficiency changed over the years? And what you're talking 96 technology was way less than
Yeah, we're making gradual improvements in the efficiency. Yeah, it's not great, and it probably isn't going to ever be that great. There's a theoretical limit on the what they call single junction photovoltaics, which is the least expensive kind. The theoretical limit is at 31? 31%. So of all the sunlight that hits the panel, only 31% of it gets actually converted into electricity. The rest goes off as heat. And right now, I mean, that's a theoretical limit. Right now, the practical side, about 18 to 20% for typical consumer grade solar